We're at 6 out of 9. I know. So we got 2 more people need to step up and do these. I'm going to send out a reminder. There's a button on here that allows you to send reminders to people who haven't done it yet, so I'll do that tomorrow for both classes. The other class is beating you, too. They're at 24 out of 29. So percent-wise. But thought I'd give the update on that. We have, let's see, a bunch of stuff to do today. We have the quiz thing to do today. Formative assessment, as it is called. So I have the starter kit that I put together in Word open that we can fill out. I looked at them this morning and there was some, I think, variability in how folks felt that they did. A little bit of trouble mapping the equations onto the code, and so we can go back over all of those things if that would be helpful. Yes, I don't know who hasn't done evaluations, but I hypothesize it is tied to class attendance, but I could not be for sure on that, so I do not know. But if you know other folks in the class who are not here, you can nag them of your own accord. I'm not going to get involved in that directly. All right, so I've got this open. Shall we walk through it? Yes, may as well. Okay. So asking for predicted outcomes and predicted simple slopes given this linear model. So we have this model with, let's see, 1, 2, 3, 4 predictors in it, and 2 interaction terms among f and g and f and h. And so for all of the numbers that I gave you, you can just pretend like you don't need to worry about centering, just put in the values direct. So that makes it a little bit easier. So first question then, write a statement for the predicted outcome. So all of these words are synonymous. The idea of a conditional mean, predicted outcome, expected outcome. That means what the model fixed effects, how they combine with the predictor variables to create a predicted outcome for each person. So E is not part of that, which is why I don't have an E in here. So what I'm asking for is Y hat, so to speak. Anybody who has the same values of these predictors would have the same Y hat. So this is the relatively easier one because all you have to do is plug in the values that I gave you in the question. So where F goes, for instance, I wanted it for somebody with an F of 2. So that goes there. A G of 3, an H of 4, can't type in front of everybody, an I of 5, and then I put the parentheses in here so that you could see where the ingredients come from. It's F and G, but you could have just written that as the actual multiplication, but I'll put that in here like that. And then F is supposed to be 2 and H is supposed to be 4. Okay, good so far? All right. So then the corresponding estimate or LINCOM statement. The values that I just typed go in each of their respective places. So the letters refer to the betas, and the values that go behind them refer to the values of the predictors. So then that goes there. F times G, then that becomes 6, and this one should be 8. And several of you made the same omission. What goes here under intercept? Is it 0 or 1? Oh, we have people reconsidering their answers now. It is 1 because I do need a beta 0. So in the matrix in the matrix version of this, by the way, there is a column of 1s that beta 0 gets multiplied by. That way all of the columns, all of the matrices are of the right size to be put back together again. So you can think of beta 0 as being the effect of just a column of 1s, meaning everybody gets a beta 0 applied to their score unilaterally. So yes, we do need the 1 here, and then we would need the same thing under LINCOM here. And I had a question, I think, from Jen. Do I have to write times 1? No, you don't. You can just write constant. But I do it that way because you do need a 1 here. And so I'm trying to keep the code as parallel as possible across programs. So status shows what the estimate statement is doing much more explicitly. It's taking beta 0 times 1 and then adding beta 1 times the value of f that I would put here, and so on. So the names of the variables that go into these program statements refer to their estimated beta fixed effects. All right, and then Stata doesn't allow you to write a title with this, and so I always put a comment as to what the lincom statement is actually estimating as my trail of breadcrumbs for the output. Okay, any questions on that one? Okay, number 2 then. Write an equation and the corresponding statement for how to get a predicted g-slope for somebody with an f of 2. So the process here, step 1 is to do what?
Look in the original equation and pull out everything that has a g in it.
Ding. So I know I'm going to need that. And I'm going to need that. Actually, don't need that after all. Okay, so that's how the model tells me what the slope of g is going to be. It is a linear combination of 2 terms. Now what do I do?
Okay, so this is where I could be confused, but as far as I remember when we were doing the age one and the one with the women and men, sorry, with G, that is going to be the only, wait, am I jumping ahead a step?
No,
Oh, you want to factor out.
I'm listening and getting ready to type.
Yeah, you factor out the G, and then the next step I think is however many G's we have there is what's going to be our modifier, or the number for our modifier. I don't know. We'll see.
Factor out the G is correct. So then you're left with beta 2 plus beta 5f. And so that is the part that goes into the statement. And yes, you're not stealing each other's thunder. You're all participating. This is a good thing. So the chat window allows people to talk at the same time and not interrupt each other. It's a beautiful feature. So then beta 2 corresponds to, let's do the same thing actually for the estimate statement. Do I need this? Do I need to put anything there? No. Okay. Do I need this? What does F refer to?
Beta 1.
Beta 1.
Yeah, do I have a beta 1 in here? No. This is the tricky part, because you look at this F and it's like, but I need it for F of 2, so I need to put 2 there. But no, it's the main effect of F that this refers to, and we're trying to estimate the slope of G. So the slope of F has nothing to do with the slope of G. So we don't need that. Do I need something here for G? Yes. What do I need here? We got 1 vote for 2, a couple votes for 1. What does G refer to? Which part
Beta
is?
2,
Beta 2.
but not beta 5, which is where I got mixed up on the 2.
So I need 1 slope of G. Because at a minimum, how do I get the slope of G for any person? Has to start with the slope of G all by itself. I know I need at least that much. Do I need anything for H or I? I do not. Now what goes here? We got 1 vote for 1. We are estimating the slope for somebody with an F of 2. Got a couple votes for 2. Yeah, it is 2. Yes. Because now we're filling in this part. Beta 5 times the moderator value. So we want the G-slope for somebody with an F of 2. Beta 5 is the F by G part, and then 2 is the value of the moderator for which we want the G-slope. And last but not least, do I need anything in here? Nope. So that's it. Just those two things. So you don't have to type zeros in all the other places. You can remove them from the statement. That makes it a little cleaner. I tend to leave in zeros for terms that could possibly be something else. So like if I asked you, what would the g-slope be for somebody with an f of 0, then this would become 0 because that changes as a function of what f is. And I would probably write it this way in my code to remind myself that this part could potentially be something else if the value of the moderator were something other than 0, like 2. Okay. Any of that you want to hear again or ask me more about?
So just for clarity, the Stata one would be just lincoms is a constant 1. The f would be, well, we would delete everything except the g and the f of g,
Yeah, so
or f times g.
the intercept is gone because we're estimating a slope, and the intercept has nothing to do with that. So yes, so if I do the Stata one, then I need that gone, and that gone, and that takes a 2, and that takes a 1 that you don't have to type. It could just be g by itself. Yep. Okay, other questions on number 2?
I don't think I have a question on 2, Lisa, but do we follow this same logic for the other 3, or the other 2 as well, coming up?
Yes, you do.
Okay. I think I just made it more confusing than was necessary, so that definitely makes sense. I'm just trying to think ahead and make sure I know what's coming, so yeah. Okay, thanks.
Yep. So the f slope is the same way. Step 1 is to find all the things that have f in them. So we have this at a minimum, and then we pick up 2 interaction terms in this case because they both contain f. We factor out the f part as the common variable that we're estimating the slope for. I'll just get rid of that. Like that. Okay, so now we have our ingredients. So we want the f slope for somebody with a g of 3 and an h of 4. Okay, do I need anything for the intercept? No, I do not. Anytime you're estimating a slope, the intercept does not go in there. So we'll get rid of that here. We'll get rid of that here. Do I need anything here for f? Yes, I need a 1 because f refers to what? Beta 1. And in my ingredients, I need at least one of those. So f1 refers to the existence of 1 beta 1. So put a 1 there as well. Now, do I need anything here? I do not. I do not, because those are the main effects of each of those predictors, not the interaction terms. They have nothing to do with the f-slope. They are separate slopes for other variables, so they're gone. Now, what goes here is a function of the moderator. So in the ingredients list, we're up to here. So f times g refers to beta 5, which means what goes in the blank for the moderator? 3, the value of g. Yes, indeed. 3. And then last but not least, what goes here? 4. You got it. So now I have to know 2 other things about a person to be able to give what the model says their slope of f would be. I have to know their g value and their h value because the slope of f is moderated by both of those variables. Yes, indeed. Okay, last one. Historically, no one gets this right because they overthink it. So let's see if history continues. I've looked at your answers, but you can reconsider relative to what you would have written yesterday. So step 1, right? Step 1, find all the things that have I in them. Step 2, factor out I. All done. That's it. So the question said, ask for the predicted I slope for ... The rest of it is irrelevant. Because the model says the I slope is the same for everybody. The model says the I slope is given by beta 4 only. So it is the I slope for an F of anything, a G of anything, and an H of anything. So this is an instance in which you wouldn't have to write an estimate statement of any kind, because you would get that slope beta 4 as part of your regular default output solution for the fixed effects. So I'll just finish this up here. There. Ta-da! Yeah, it's a little tricky, but I was making a point. It was a purposeful tricky.
So am I the only person ever who got this right?
I am never going to reveal, but I will say that most people try to put all the numbers in somewhere, because that's what they had done for the other questions. But this is designed to illustrate the idea of a marginal main effect versus a conditional main effect. In this model, I is a marginal main effect. The slope of I applies to everybody. Whereas, like beta 1, this is the slope of F for somebody with a G of 0 and an H of 0, because that's the only time when these latter terms would drop. Likewise, this is the slope of G when F is 0 because of this interaction term. Beta 3 is the slope of H when F is 0 because of that interaction term, and I is not involved in any interactions, and so it is the slope of I. So all of these ones I would call conditional main effects. Other people would call them simple main effects, but we agree that they are complex main effects last time, because they are specific to interacting predictor values of 0. All right. So why am I drilling this so hard? Because this is something that I see people screw up in results sections all the time. Because it is very, very tempting in these models to look at the solution for fixed effects, for instance, and look at the result for the G slope here and say it's non-significant and therefore G is not related to my outcome. But that's not true. G is not related to your outcome for people with an F of 0, but at some other point on F, G could matter. It could become positive or it could become negative based on the pattern of the interaction terms. So I just want to hit the point that in these models, the slopes that you get as part of your output are only some of the possible slopes that the model predicts for you. All right. Anything else on this before we call this one done?
So can I ask a question, Lisa?
Please.
So when I was working on this, it took me 2 attempts to get them right. But so they don't come naturally to me. Like whenever I in order to answer them, I had to review your lectures and notes like multiple times. So do you think that if I continue in this path of research, I need to make these into my second nature of sorts? Or could I always rely on lectures and notes to get them right?
I think that you can rely on the strategies. So just the idea of writing out the equation, pulling out the terms that are relevant, and then factoring, like that will always get you to the right place. I think it gets easier with practice to see what it should be. So
because when you were asking me questions, I can't answer them. I need to look up the numbers because it's not second nature. I need to look up the notes to get them right. Yeah.
So you mean you're not an expert at something that you learned 10 minutes ago? Join the club, right? You all are so hard on yourselves. It's okay to have to look at your notes for something that you're just getting started with. It's okay to have to look at your notes for things that you should know already. So no lie, I'm doing these exact same concepts in the advanced class that meets after this in longitudinal models. There's just a lot more interaction terms and a lot more other things going on at the same time. But I was working on one of my examples and I went through one of these statements and I was like, is that right? I don't think that's right. Maybe it is right. And I was going back and forth. I wasn't trusting my own self. So what I did to make sure that it is right is to recenter the predictors. So for instance, if I'm not sure if this is the right way to get the slope of f, then what I can do is change g so that it's centered at 3, and change f so that it's centered at 4. And then the slope that comes out of the model that would have been given by this statement should match. So you can always hack it to test your intuitions about whether you're getting something right by recentering your predictors and re-estimating the model. And as I think I told you, that is how I learned how to do this initially. It wasn't until much later when someone showed me this and I was like, oh my God, this is so much easier. But yeah, the idea of linear models and interaction terms and all of that shows up in so many areas of statistics that I think it's important to get exposure to it from the get-go. That way it isn't overwhelming in the context of more complex models at the same time. But yeah, it's okay. There are a number of regression type textbooks that talk about interaction terms. There's a classic, do you know the Greeny Weenie series? Have you heard of these? So it's the Sage little green book series. They're like little books and they're like maybe 80 pages a piece. There's one that is all about interaction terms and regression. I'm guessing the library probably owns all of these, but yeah, we call them Greeny Weenies. So, because they're green. But anyway, that would be a good place to go as well. And there's a million articles about, this is called probing interaction terms, which is a word that I absolutely hate. So I don't ever say it that way, but you're not the only one who doesn't find this intuitive. Let's put it that way. There's a lot that's been written on it. Okay. Other questions? Yeah, team notes. Yeah, I wish I had a better textbook for this material, but honestly, I don't like any of the ones that I've seen. So this is on my list of things to think about writing is an introductory level textbook that I think would set people up better for the advanced classes, which is the way that I'm going about this. So, anywho, would it be helpful if I posted this after class? Just so you have it for your records? Okay, I can do that. There. Then we were in example 6 last time, I believe. Shall we head back there and do some more practice with this? Simple slopes, as we call them, complex slopes. So in this example, we had done the main effects models, and we had started on the model with 2 interaction terms, as I recall. I think this is where we were. Does this sound about right? Would this be a good place to start? Okay. And note, yes, this is the example that follows your homework most directly. So week 15 is not time for subtlety. I'm just giving it to you. Like, look at this one and make it match. So in your homework, you have an outcome of Scrabble performance, which is predicted by whether or not you're playing an easy opponent or a difficult opponent, your verbal ability, but also your spatial ability. And then I'm asking for interaction terms as to whether or not the effect of verbal ability is moderated by opponent type and whether or not the effect of spatial ability is moderated by opponent type. Would you like to hear the story of where this homework came from? It's based on a true story. So approximately, oh goodness, I'm going to go with 10 or 11 years ago. My then boyfriend, now husband, and I went on vacation over winter, and we went down to Sanibel Island in Florida. And we got a little like 1-bedroom condo, Airbnb kind of thing. And it was owned by older adults, quite clearly. And they left us some materials to amuse ourselves with, one of which was a game of Scrabble. And I had actually never played Scrabble. Somehow I had avoided it my entire childhood and my adult life. And it turns out I am very bad at Scrabble. I was concentrating so hard on like making words that I wasn't paying attention to where you put them. But I have since learned that it's all about, the double word scores and the triple word scores and all of that, and you have to like use the space. So my hypothesis was that spatial ability is just as important as verbal ability. And after we left the island, we did not get a Scrabble board to play at home, but we did pick up words with friends on our phones. Do you play this game? We call it phone Scrabble. So I play with my mom, I play my aunt, I play my niece, I sometimes play my brother, and I play my husband, and he still beats me. I have like a type 1 error rate of beating him at this game, approximately 1 in 20 tries. But there was, I think a year later, we ended up on another trip that was for work. So I was part of the executive council of this group, the Society for Multivariate Experimental Psychology. I was the coordinating officer, and they had a mid-year meeting at the place where the annual meeting was going to be, which was a resort in St. Pete's Beach. So it was Florida in February, paid for. I'm like, yes, I will sign up for that. And so Jonathan went with me down there. So there was one Saturday where I was trapped inside the hotel in an overly air-conditioned room being talked at all day long, right? Like inside this meeting. And he went to the beach. So we meet up after my meeting's done at like 4:30. He comes in, kind of sunburned with this cup. He's like, hey, baby, how's it going? And I'm like, what do you have there? He's like, it's a rum runner. Like, do you know what a rum runner is? It's like a big gulp cup where this much of it is alcohol and they put just a little bit of mixer on the top. I'm like, how many have you had? He's like, 4. Is it really good? You want some? So we're just hanging out in the room, before dinner trying to decide what we want to do. And he's laying on one of the beds in the hotel room and I'm on the other, and we're just sitting there playing phone Scrabble. And he is literally passing out between turns. Like, he'd play a word, fall back on the bed like this. And then the phone would ding when it's time to turn again, pop up, play the word, pop up. And so I'm watching this happen, and I'm like, how are you still beating me? Like, he's 200 points ahead, right? And he's passing out in between turns. He's like, I'm fucking gifted. So that's what he said. It's one of my favorite stories about him. And the irony is that he is. He is fucking gifted. But I have learned from him that spatial ability matters in playing Scrabble. And if you have very good verbal ability, then having bad spatial ability can hurt even more, because then you can't see where to put your wonderful words. It's like a whole thing. So the original version of this homework ended up with a 3-way interaction of opponent by verbal by spatial. I decided to take it easy and just drop it down to 2-way interactions for this class, but it is based on a true story. So yes, your EF Lindquist chair is fucking gifted. He said it himself. But he is. So, was the drunk husband the easy appointment? Yes. He was the easier version, I would say. Because the hard opponent is when he is completely sober, which he is most of the time, which is why this was such a deviation from character. So, but it was vacation. And I did get out on the beach the next day. So, and the rum runners are very nice, I'll tell you that. Highly recommend. So, anyway. Back to the story. In your homework, you have a binary variable for opponent that you can dummy code in the same way that we had a binary variable for gender. So you can make the easy opponent the 0 and the difficult opponent the 1, and then you can treat it as a regular predictor. Yes. Would not recommend giving rum runners to children. That seems like a bad idea, but maybe phone Scrabble. So. Yes, my 12-year-old niece is the one person I can reliably beat at phone Scrabble. And yeah, I don't take it easy on her. Because, someone's got to learn. But anywho, I don't take it easy on you guys either. Look at this. We have 2 interaction terms in our general linear model. So we have, do you remember the story for these data? These are real fake older adults. We have age centered at 85, grip strength as a measure of frailty, centered at 9 pounds per square inch. We have a dummy code for men versus women, and then we have 2 dummy codes that differentiate the 3 dementia groups, none versus future, none versus current. And so then we're adding in the 2 interaction terms. And I have a couple of pieces of code here. This one gives me the missing pairwise comparison from my dementia groups, since I have the future versus current that I might also want to know. This one lumps together the 2 slopes for dementia groups so that I get an overall, or what's known as an omnibus test of group. And then this one lumps together the two interaction terms for whether or not they've added to the model relative to just having the main effects in there. So then I have simple slopes. So following the ingredients that we just reviewed here, if I want to know the age slope, step one is to go up to the equation, shorthand for which is right here, and pull out all the terms that have age. So age shows up in two places, as a main effect and as an interaction with gender. So we have the main effect of age, and then we have the interaction of age by gender. If I pull age out, then these are the ingredients that's left. And so why do I have a 1 right here?
Because you've got one of that term.
Yeah, I have 1 beta 1. That's why. Yeah. And why do I have a 1 here?
That's the beta 6 that you have in the other one,
Mm-hmm.
the one above. Yeah.
Yep. The 1 represents which gender I want the age slope for. And women are the 1 in my coding scheme. So that's why it's 1, and that's why this is 0. So this would look a lot like easy versus difficult opponents. Same thing with grip strength. In that case, we have 2 terms that have grip strength in it, the main effect and its interaction with gender. And so the code is very much parallel, where we have what is the slope that you're estimating first, that gets a 1. And then for what value of the moderator do you want each of the slopes? And so it's 0, 1 for men and women respectively. And then predicted outcomes. So you have a series of these on your homework as well. Don't forget that when you're generating a predicted outcome, every fixed effect potentially goes in the model. So in this case, I am holding the dementia group outcomes constant because they don't have any interaction terms involved with them. But otherwise, I have all of the terms represented in each of these estimate statements. So intercept gets a 1 because at a minimum I need a beta 0. And then we have the value for which we want the prediction for each of the main effects. And then the interaction terms are the literal multiplication of whatever you wrote for these values right here. Okay, so any of the SAS code that you want to go over anymore or ask questions about? So then we'll look at this data in just a second.
Can I ask one question, Lisa? So if a variable is coded already as 1 and 2, two levels of the category, then and then should I recode that using dummy codes of 0 and 1? Is that a requirement, or could I just go with the 1 and 2?
It is, if I asked you for the fixed intercept to check your coding, then it is a requirement. Otherwise, you would, in theory, you could just put in the 1 and 2 here instead, and you'd be fine. You'd still get the right answer. It's just that the main effects of age that come from the model would be for the group 0 that you don't have, which would be weird, but it's not wrong. Let me put that back here. Yes, and in this case, you can just subtract 1 from the variable to make a new one. So it's more straightforward. Okay. Other SAS questions? All right, then Stata, folks. Yours looks very much the same. I have C dot in front of all of these variables. Note the line continuer. Have we talked about that in this class? I think we have. Yes. Yes, because Jin was renaming all his variables to make them fit on a line, and he didn't know he didn't have to. See, I did teach you something this year. The line continuer allows it to wrap. So all of this, according to Stata, is one command. SAS doesn't care, but Stata does. The lincom is used then to get the missing mean difference, and then the analog to contrast are these test statements where the parentheses denote numerator degrees of freedom. And then the simple slope of age is the same idea here. We need 1 beta 1, and then the value of the moderator is for which gender you want the age slope for. And the same thing with grip strength. We have, at a minimum, we need 1 beta 2, and then the value of gender that you want as the moderator for who you want the grip strength slope for. And this, which saves you a lot of time in writing predicted values. So it is inside the parentheses here, I'm asking for a range of predicted outcomes from the first value in increments of for the middle one, and then to the last one. So to match the SAS code, I'm only generating predictions for plus or minus 5 and plus or minus 3, and then for men and women, so just 0 or 1. Yes, I taught you lots of things. That's good to hear. And hopefully I taught you that algebra is your friend. He's not having it. Okay, fine. But it does get you to this stuff. I think technically we're doing differentiation too, not just algebra. We're taking the first derivative with respect to the variable, but shh, I didn't tell you that. All right, so we did talk through the output, as I recall, with respect to the model. Do you want to go through that again, or do you feel good about at least sort of the standard stuff here up here? Feel good? Feel good. Okay. Then we talked about eta squares. This is not something that I'm going to ask you about on your homework within each model. The only thing I'm asking about is the change in R square relative to having only the main effects in the model after adding in the interaction terms. And that's the one instance in which you can get your calculator out and subtract. So you have the R square for section 2 minus the R square for section 1 gives you the change in R square that arises from adding the interaction terms. And the test for whether or not that change in R square is significant is the multivariate wald test of lumping those two new interaction terms together and asking for a joint test of their significance. All right, then, yeah, we did this a little bit. Yeah, we did do this. No, I'm remembering this, but just for shits and giggles, since I'm already swearing today, I may as well bring out all of my favorite expressions. Shits and giggles. The grip strength main effect here, who is this for?
Men.
It is, and how did you know that?
Men are 0.
Men are the 0. So yes, because grip strength is involved in this interaction, this effect of grip strength is conditional. Likewise, because age is involved in this interaction, that's the age effect for men, making the age slope conditional. And because gender is involved in both of these interactions, this gender difference is conditional on 85-year-olds with 9 pounds. And then what about these two? Are they conditional on anything? Nope. So I would call them either unconditional or marginal. So this is like the variable I in your in formative assessment, the last question. It doesn't, these are the dementia group differences for everybody, regardless of age, gender, or grip strength. So then what would we say about the grip strength slope in women? So the coefficient for grip strength we said is for men. So in men, for every pound you can squeeze, additionally, your cognition is predicted to go up by 0.7. What happens to that slope in women? Yeah, it's less up. It's still a positive slope, but it is less positive. It's weaker, I would say. So yes, grip strength matters less in women. The p-value tells us that it's not significantly less, but I'm more interested in making sure you know what to do with the coefficient, because the p-value part's the easier part. Less than 0.05 or greater than or equal to 0.05. So do we have anything on this table right here that tells us if grip strength is a significant predictor in women? We don't. So this is what the model gives us as the solution for fixed effects. These are all of the betas that we asked for in the equation. The model tells us what the grip strength slope is for men. The model tells us how the grip strength slope differs for women. It does not directly tell us what it is for women. That's why we had the estimates and the lincoms, is to get that linear combination that results from taking this grip strength slope and adding to it the interaction term. So that's where the results down here give us the extra pieces of information. So here's the two grip strength slopes that I asked for. The first one is not strictly necessary because it's the same thing as the grip strength slope that's given by the model. It's for men. But then now we have what the model says the slope is for women. So the grip strength slope for men plus the interaction term times 1 for women gets us to this one right here. So in practice, even though this slope is given by the model and this slope is given by the model, I always do this. I write the estimate statement even for the reference group, because 6 months from now, I'm not going to remember what's what. And this is my trail of breadcrumbs to myself to have these things nicely labeled. Like, this is a table you can send to anyone, right? This is the table that you can stick Times New Roman on and put into a document. So I like doing the estimate statements to do the heavy lifting of understanding the model predictions, like, all up front, and then you have the results of that. And these predictions I would then put into a chart. So we'll look at the picture that I made with this in just a moment. So Stata Output is very similar. One thing to keep in mind, Stata folks, is that for reasons that I do not understand, it always puts the intercept last. So just get used to that. It does it in all of the Stata procedures. And then it spits out each of the lincoms as separate things here. So like here are the age slopes, and it spits the code that it used to create it first. And so that's where you'll know what this estimate is referring to, is based on the comments that you write in your syntax. So it's very important to label those to help yourself on the back end to know what is what. And what's this telling me right here? It's an F test. Can you tell based on the context what it's telling me?
Is it the significance of the interaction
Which interaction?
between sex and age and sex and grip?
Yeah, both of them. Yeah, it is the combined test of these two slopes against 0. And I am doing that as a direct answer to the question, did adding the interaction terms improve the model prediction? So I'm lumping them together to get at the change in R-square that results from adding those two interaction terms simultaneously. So in other classes, this would be part of a hierarchical regression. You get a change in an R-square after you add layers of predictors at each step. You can ask for it. You don't have to do it in actual layers if you don't want to. And so yes, the p-value is greater than 0.05, therefore, nope, didn't help as a set. And do I have a picture? I don't think I do have a picture. Good. So Stata made these pictures for me. We have the grip strength. Let's see, we have the age slopes on the x-axis in this picture, separated for men and women and by grip plus or minus 3, since I had asked for all of those. And so what this is showing is that there is a difference in the age slopes between gender. On the right here, there is a difference between the grip strength slopes between genders, but it's not significant. So functionally speaking, these red and blue lines are parallel. So then to get all of the eta squares from Stata, I had to do an extra step. I had to estimate the model without the interaction terms to get what the sums of squares for that model would be. I then plug them into the eta square formula, which is for the full model that contained the interaction terms minus the model that did not have them divided by the total, and that gets us the semi-partial correlation squared for those two interaction terms. So in SAS, this number came out directly from using contrast to get the F-test. In Stata, I have to do it as a separate step. All right. And then, yeah, pictures. So these are the pictures that I made in SAS. I have the grip strength slope on the left here and the age slope on the right, but the story is the same. The model is telling me that because neither of these interaction terms were significant, both of these are functionally parallel. One thing that's different about my plots is that I extended the y-axis a lot further than Stata did. When you're making these sorts of pictures, be very careful to not cheat the y-axis. So like it's real easy to blow up the y-axis to like zoom into the scale, and it makes it look like the interaction terms are more prominent than they are. So like this scale goes from 15 to 45 because that was roughly like 2 standard deviations around the mean. So I'm trying to show like what the full length of the y variable would look like. Whereas when Stata made those pictures, it plotted it from 20 to 35. Which is a zoomed in picture, which makes the interaction look a little bit more prominent. So that's one thing to watch out for, is to control the y-axis so that it looks like it is a fair depiction of your results. And I'm not asking for any pictures. All right, and here's some words, as always. Okay, yes. So any questions on that model? Okay, do we have enough stamina for one more for today? One more model? Can we handle it? We can handle it? All right then. So this is the model that is discussed at length in chapter 2 of my book. So the code that goes with it then, I am taking out the 2 interaction terms that were not significant since we don't need them, and I'm adding in another one. So age by grip as a new interaction term in the model, so that's up here as beta 6. So conceptually, I'm asking if age matters more in stronger people, or if frailty matters more in older people. That's the idea of this interaction term, is to look at those types of moderation here. So a couple examples of estimate statements, the same as before, to get the missing dementia group contrast, to put the 2 contrasts for dementia together. And then this is an example of a custom hypothesis test. If I wanted to ask what is the net contribution of age and grip strength working together, I could lump together the main effects of age and grip strength as well as their interaction term. So I will get an F test and a semi-partial eta square for those 3 terms lumped together by asking for it in this contrast. Okay. So then simple slopes time. If I want the simple age slope for any level of grip strength, I go up to my equation, I find all the places that have age, right? I want the age slope, right? Maybe? Yeah, not rhetorical. Hello, hi, are we here? Yeah, we're here. Welcome back. Age slope here, age slope here. So age shows up in 2 places. So let's bring that down. Factor out age as the common variable that we're getting the slope for. And here is the ingredients to get the age slope. So then if I want the age slope for somebody with a grip strength of 6, at a minimum I need 1 beta 1. That's why we have 1 after the age. And then I need the value of the grip moderator at which I want the age slope. And because grip strength is centered at 9, if I want it for somebody with a value of 6, it's -3. Do you remember why I picked plus or minus 3 as this example? Yeah, 1 standard deviation either way. Either way, by the way, is plus or minus 1 standard deviation. That's how the stats folk would talk about it. Plus or minus 1 standard deviation as a common way of describing interaction terms. You don't have to do it that way, but that's a very common thing to do. So good job. The middle one is the one that's already given by the model. So the so-called simple main effective age is the effective age for somebody with a grip strength equals 9 because that's where the variable is 0. Likewise, if I want the simple effective grip strength, flip the story. I pull out the main effective grip strength and the age by grip interaction, but this time we factor out grip. So I need 1 beta 2 to start this off, and then I need the value of age that goes in here. So this is potentially confusing. Let me highlight, say, this one and this one. It's the same term, but the numbers that go in there are different. It's a question of, at this point, what's the moderator and what's the predictor? Up above, age is the predictor and grip is the moderator. So we put in values that correspond to grip strength. Down below, grip is the predictor, age is the moderator, so we put in values that correspond to age. So what goes in here is entirely contextual on what you're estimating. And then here's some estimate statements to illustrate combinations of plus or minus 5 and 3. So low, medium, and high for grip strength and for age. And Stata code then looks remarkably similar. We have the same 2 F-tests requested here. We have the same lincoms to get age slopes at grip at each value of grip, as well as to get grip slopes at each value of age. And we have this thing. Have I talked about this in this class yet? I can't remember. And now I'm frozen. I got the dreaded unstable message. Am I still here? I'm still here? Hooray. Have I talked about this margins thing yet in this class? I can't remember. I'm pretty sure I did in the other one, but I'm getting interference between the two. Okay, so yet another reason that the Stata folks like Stata. This command allows you to get simple slopes across a range of a moderator variable in one line. So I am asking for the effective age. The dy dx command means that first the derivative of, with respect to x of this function y, and the at allows us to get it over a range of values. So that one margins line gives me, is the equivalent of writing all 3 of these lincoms. Pretty slick. So I could change where it starts and the increments, and I could get as many of these as I want in one line of code. Same with the grip code down here to get the grip strength slope with age as the moderator. Note the placement. The dy dx is the variable that you want the slope for. So it's age up here, and then it becomes grip down here. The moderators at which you want that slope then go into the at part of the line. And the same thing with the predicted outcomes. I'm asking for a range of low, medium, and high. So this one line of margins gives me all 9 predictions I had to write out separately in SAS. Okay, so Stata folks, any questions on the Stata code to do this? No? None yet? Fair enough. Then let's see what happened. So, quick review, what does this F tell me?
Significance of the model.
Yeah, all 6 slopes in the model. So numerator degrees of freedom 6, denominator degrees of freedom 543. Conceptually, what is denominator degrees of freedom? What does 543 tell me?
All the slopes that we could have had.
Yeah, based on sample size. How much more complicated I could have made the model. Yep, but didn't. So the model is significant. It accounts for about 29% of the variability in cognition. I have my semi-partial eta squares that tell me what the effect size is for each of these terms in terms of its contribution to the overall model R square. I have a note here about what is conditional. So in this model, I have age and grip as main effects, but I also have them in an interaction term. So these effect sizes are going to refer specifically to those main effects when their interacting predictor is 0. So this is the contribution to the R square for age, specifically for people with grip strength equals 9. Likewise, 2% down below here is the contribution to the R square for grip, specifically for 85-year-olds. And the interaction term adds another 1% or so to the tally of overall R square. And by lumping those three terms together, age, grip, and their interaction takes up about 6% of the total variance. Question, did SAS type this interpretation for me? What do you think? No, SAS is not going to interpret your results for you. Absolutely not. I know. It could, though. It could. It's algorithmic, but no, it doesn't. No, this is me being nice. This is me being nice and typing this as annotations out here. Part of the reason...
Yeah, I was looking for those options yesterday to find out, like, like these could answer my questions, but I couldn't see those messages, and I looked up online and I didn't get anything.
No, there's no proc results section, proc discussion, proc taxes, proc living revocable trust. There's none of that can actually help you in life. This is you know what they call that in my field? We call this job security. That's what we call this. You make the output inaccessible to most people, and then people like me have to be paid to explain it to you. But my hope eventually is that all of you will have job security because you will have cracked the code of how to interpret this stuff as well. So then we have F-tests down here. So these are the effect sizes that go with those F-tests. And then the solution. And yes, this is me being nice, writing the betas out here as well. So let's go down the list here. Intercept. Who is this the intercept for? And yes, stats prowess is indeed relative, Alex. You are correct on that. Who is this the intercept for, according to this model? What kind of person is predicted?
We didn't change, and it's still for men that are 85. Or
men that are 85, and?
Oh, with a grip strength of 9?
With the grip strength of 9, and?
And no dementia or signs of dementia?
That's right, no dementia. Mm-hmm. So that is our reference point for the model, the you are here sign, as it were. Is this effect, age, conditional or unconditional?
Conditional, because it's in another term.
Ding, that's how you know. It's part of something else. You can't just call this the main effective age. This is the main effective age for what kind of person?
A guy.
Nope, not a guy.
One of those people. One
of the people, okay. Gonna need a little more specificity on that one. Do you want to phone a friend, Jerome?
Yeah. Since it's almost class is over, Jen, how about you go for it? TA Jen.
Wow. Okay. Thanks. A grip of 9. Okay.
Yeah. It's grip of 9 because that's who they interact with. Age doesn't interact with gender. That's why it's not specific to a man. Age doesn't interact with dementia, so it's not specific to that either. Likewise, this one. Conditional or unconditional?
Complex.
Complex for whom?
It is simple.
Who is this the grip strength slope for? What kind of person?
The 85-year-old?
Yeah, 85-year-old. So it works in both directions. Right? And what?
85-year-old men.
Not a man.
Dang it.
Yeah.
Jen, I should have just let you keep it.
It's because grip strength doesn't interact with gender in this model. So I think that's the part that you're making an extra conditional based on the two interaction terms that I took out. So the gender interactions are no longer in here because they were not significant. If they were in here, it would be for a man. Yep. And then how about these three? Conditional or unconditional?
Not conditional.
Unconditional. Give me a synonym.
Unique.
Marginal.
Marginal is the synonym. Unique is a different idea.
That is correct.
So unique has to do with whether or not it is the effect of that predictor controlling for other stuff, which is unique, or not controlling for other stuff. So all of these slopes are unique. They're all controlling for each of the other slopes. They each represent what they individually bring to the table that no other predictor does with respect to capturing outcome variance. So we're adding another layer to the unique. It's unique conditional or unique marginal, meaning that this is the gender difference for everybody. Marginal. It's the gender difference after controlling for age, grip, and dementia, but it's a marginal gender difference for everybody. Same thing with this. This is the dementia group differences after controlling for gender, age, and grip, but these are the dementia group differences for everybody. So then let's do this one and this one, the main effective age and the interaction term. Which of the four kinds is this? Your choices are: the interaction term is making the age slope more positive, less positive, more negative, or less negative. Age slope is negative, interaction term is positive.
More positive.
Age slope is negative, interaction term is positive.
Less negative.
Yeah, this one's less negative. It will,
So you always go with what the first one, or what the first predictor is?
So it becomes less negative, it approaches zero, but if you go high enough on grip strength, then Fayaz, you're right, it becomes more positive. So it's moving in the direction of less to more. But because it's already starting from a negative place, the way that I would describe it is that it's becoming less negative as grip increases. How about, so if I put this in a sentence, what do I do with the coefficient, the 0.12? Don't know. This is tricky. The trick to interpreting the coefficient is to not start with what happens to y. You start with what happens to the main effect slope.
Age has a significant effect on the grip strength. Significantly.
So we're going the other way at this point. We have the grip as the moderator. So grip strength has a significant effect on the age slope. For every pound stronger, the age slope becomes less negative by 0.12. So I'll say that again. For every pound stronger, the age slope becomes less negative by the interaction coefficient of 0.12. So when we're talking about what the slopes do, we talk about what happens to y. So for every year older, y goes down by 0.33. When we talk about the interaction term, we talk about what it does to each of the main effects. For every unit stronger, every pound stronger, the age slope becomes less negative by 0.12. And if we go the other way, which pattern is this? What happens to the grip strength slope that is positive as a function of age? Positive grip strength slope paired with a positive interaction term. What does the interaction term do to it? More positive, yes indeed. So in this case, the effective grip strength for an 85-year-old is an increase of 0.6 on the outcome per pound squeezed, that slope of 0.6 becomes more positive by 0.12 per year of age. So in English, because after you write all of that, you got to give them a sentence that they can actually highlight. In English, strength matters more if you're old. That's how I would say that. Strength matters more, meaning the positive slope for grip strength becomes stronger in older people. Grip strength is more beneficial to older old adults than younger old adults. If I went this way, I would pull out my GRE words and say something like, the deleterious effect of aging is mitigated in stronger people. How's that? Less down. Less downer with more stronger. So yes, you can use words like enhanced, mitigated, strengthened, weakened. Those are all ways to convey the idea of more or less positive or negative. In this case, it's pulling it towards 0, so that's why I'm saying the effect is mitigated. It is reduced. And so then we have the simple slopes that we asked for instance. So for instance, if we look at when does age matter? Is age important for weak people? Grip strength equals 6. Yes. There is a significant effect of age at grip strength equals 6. Does age matter for medium strong people? Yes. But the pattern is that it matters less, right? So in weak people, which is first, the coefficient is minus 0.7. At the mean of age, it's down to minus 0.3. And at plus 1 standard deviation, the coefficient is next to 0, and it's not significant. So what this pattern is telling me is that there is some point along the moderator of age at which the negative, there is some point along which the moderator of grip at which the age slope shuts off. And that happens somewhere between 9 and 12. So at 6, it's significant, looking at the p-value column. At 9, it's still significant, but by 12, it's not. So the idea of regions of significance we can talk about next time as a way to find out where along the moderator the slope of the predictor shuts off. Also, what's going to happen to it if I kept going up? If I plotted it for grip equals 15, for instance. It's going to flip to positive, right? If it already crossed 0 at this, and it would become more positive. So at some point, the effect of age is actually going to be positive if I go up high enough in grip strength. And I can calculate when that happens as well. So for quantitative moderators that don't have distinct values that you would care about, this is sort of an arbitrary way of talking about it. I think regions of significance is potentially more useful as a concept rather than just picking plus or minus 1 standard deviation. Yeah, 85-year-old with insane grip strength. Indeed. For those people, age is actually beneficial. That's what the model would say. So let me get down to a picture.
I have a quick question too
Please.
about those estimates.
About the estimates?
Values.
Mm-hmm.
Can you look at those to see less negative, more positive also?
Mm-hmm.
Okay.
Yeah,
That makes more sense in my head to look at those values for seeing it more obviously, so I don't have to think about it. But I was just wanting to make sure that that was fine to do.
Mm-hmm. Yeah, what those values are is illustrating the pattern that the coefficients are creating. And so that is the idea of probing interaction terms or estimating simple slopes is exactly for that reason. So this picture right here displays those 3 age slopes. So for the blue line, that's a weak person, grip strength equals 6. The red line is a medium strong person, grip strength equals 9. And the green line is a relatively strong person, plus 1 standard deviation for grip strength equals 12. So the pattern then is that age is a negative slope, but it's becoming less negative as you move up in grip. And eventually, if I kept plotting, the age slope would be positive. Same thing over here in reverse. This is the grip strength slope as a function of age. So the grip strength slope is positive in 90-year-olds. It is less positive as you move down in age. So grip strength matters less in younger people. It matters more in older people. All right. Other questions before we call it a day? No. All right then. It is garbage day. That means I say see you Thursday, which I think is an acceptable thing to say because I actually mean it that way. So see you Thursday, everybody. And let me know if you need anything before then. So thanks for coming. Enjoy your last week of classes.